In this video, we're going to discuss another example, finding probabilities involving sample means. So in the previous video, we did an example that used the central limit theorem. This example does not really use central limit theorem, though it is still finding probabilities involving sample means. Okay, so let's go ahead and read the problem. The lengths of rockfish are normally distributed with a mean of 34 inches and a standard deviation of 5 inches. All right. A random sample of 9 fishes are selected. Find the probability that their mean length is between 34 and 39 inches. All right, so first we need to recognize this question is not asking us to find the probability that x is between 34 and 39, right? No. This problem is asking us to find the probability that the mean of the 9 fishes, so the sample mean, probability of the sample mean, x bar, is between 34 and 39 inches. So this is a different sort of problem than the problems that we've done before. Okay, so let's go ahead and define x. X is going to be the length of rockfishes. Okay, and so then x bar will be the mean, the sample mean of the lengths of rockfishes, right? Okay, now x is normally distributed, right? It says that right here. It says the lengths of rockfish are normally distributed. So the distribution of x is normal. And it has a mean of 34, and it has a standard deviation of 5, right? That's all given there in the first sentence. All right, now what's the distribution of x bar? And then we can't use central limit theorem because the sample size is not more than 30, right? Remember in the previous video, we discussed how central limit theorem really only kicks in for sample size more than 30. Now, there's another cool fact that you need to know, which is that if the distribution of x is normal, then the distribution of x bar is normal, right? And this makes a lot of sense, that if the original data is coming from a normal distribution, then if I were to go and get, a sample, it doesn't matter what the sample size is, even if the sample size is 1. Well, the original data was normal, so of course the distribution of any, sample mean statistic that you were to calculate from that, from those normally distributed data should also be normal. So the distribution of x bar is normal because the distribution of x is normal. So this is not by the central limit theorem, but just because the original data was normally distributed. So it doesn't matter what the sample size is. Sample size could be anything. All right. So well, we still need to know what's the mean and standard deviation of x bar. Well, it turns out that these are still the same as the central limit theorem's mean and standard deviation, okay? So this mean is still the mean of the original data, and this standard error, right, standard error, because it's the standard deviation of x bar, is sigma over the square root of n. Okay, so we'll still be using the same z formula that we discussed in the previous video, which is x bar minus mu over sigma over square root of n. Okay, so we still have the exact same equation. It's just now the distribution of x bar is normal for a different reason. All right, so let's go ahead and get to solving this problem. All right, so this problem is asking us what's the probability that the sample mean, that the mean is between 34 and 39 inches. So actually I should write the sample mean between. So 34 and 39 inches. All right, so let's go ahead and draw this. I always like to draw my distributions first. Okay, so here's my distribution of x bar, and it has a mean of 34, and I'm trying to find between 34 and 39. Okay, so I'm trying to find this area here. Okay, all right, so I know that my first step is going to be changing over these values, 34 and 39, into the corresponding z values, right? It's always the first step. So here's 0, Here's some value. We don't know what it is yet. We do know that 34 is going to be 0, though, because 34 is in the center, right? 34 is the mean. Okay, so here we go. I'm looking for what is this area here. All right, so let me go ahead and write this. So the probability that x bar is between 34 and 39, it's going to be the same as, okay, so I'm going to go ahead and transform. I'm going to transform these 34 and 39 using this transformation up here. Okay, so I'll go ahead and do it for the 34, even though I know it's 0, right? Because 34, right, that's the 34, minus the mean. Now, the mean is 34 as well. So there you go. That's how it zeroes out. Divided by sigma. Now, sigma is 5. Okay. And that 5 divided by the square root of n. Okay. N is 9 in this, right? A random sample of 9 fish. So square root of 9. All right. Now I've transformed x bar to a z, so I should write z there. Okay. Now I'm transforming this 39 to figure out what this corresponding value is right here. All right. So 39 is now the value of x bar in this formula, minus mu, which is 34, divided by sigma, which is 5, divided by the square root of the sample size, which is 9. Okay, let's go ahead and simplify this, calculate some of these things. So this is 0, right? 34 minus 34 is 0. And then z is still in the center. Okay, and then this is, looks like that's going to be 5 divided by 5 over 3. All right, so be careful when you're putting this in your calculator. This 5 over 3, you need to calculate that first. This is the 5 over square root of 9. All right, you need to calculate that first. So let's go ahead and plug that in. 5 divided by 3 is 1.666. Now, you should round this to at least 3 decimal places. So I'll round it to 1.667. Okay, so why is it at least 3? Well, because z, you're going to round to 2 decimal places. So you want to make sure that you don't mess up your calculation of z. Okay. Okay, due to rounding errors, right? All right, so let's go ahead and calculate that. 5 divided by 1.667. 1.667. Okay, I'm going to round this to 2 decimal places. Remember, z gets rounded to 2 decimal places because of the restriction due to your table, right? So that 9, these 9s bring that up to a 3. Okay, so 3.0. All right. All right, so this number here is 3. Okay, now trying to find this area that's between, right? Remember, don't forget the trick to figure out the area between, right? First you find the area that's behind 3, and then you subtract off the area that's behind 0, okay? So let me go ahead and write that. This is going to be equal to the probability that z is less than 3, and then subtract off the probability that z is less than 0. Okay, so let's look up 3 and 0 in our table. All right, so on our table, here's 3, 3.0, 0.9987. Right? 0.9987. And we don't need to look up 0. We know that half of the distribution is behind 0, right? Because this is a symmetric distribution centered on 0. If you did look up in the table, it is there, so you could see it. It's 0.5, right? Because half of the distribution is behind 0. Okay, so lastly, let's just go ahead and calculate this difference. So 0.4987. All right, there you go. So the probability that the average length of the 9 fish will be between 34 and 39 inches is 0.4987.